find the sum and difference of a sinusoidal, kind of looks on there, function. So these are the two functions they've given us. It's a voltage type question. And we have alternating current for voltage is equal to the function 10 sine t, t representing over time, and the voltage of direct current is equal to just 15. In the question, they've asked us to put sketches of these, okay? So I'll quickly, we'll do the direct current first. What would a sketch of this be, a rough sketch of this function? Have any idea what it would look like?
Just a line.
Yeah, it's just a horizontal line at the number 15, right? That's pretty straightforward. And it's direct. The idea is direct current, so it's straight, just like this. A rough sketch of this value, oops, let's not do that in red, of our alternating current, okay? If we take a look, our normal function is written as sine x, and this is the a. Our 10 is essentially the a value. That's the only value outside. And a is also known as the amplitude. So the amplitude of this function is the value of 10. So this essentially goes up to the value of 10, and then down to the value of 10, up to the value of 10, down to the value of 10. And assuming we're kind of working in radians, this is your pi, this is your 2 pi, and we have a max value, okay, for this at 10, and a min value of this at negative 10. Okay, so those quick ideas. And we can confirm by saying 10 sine x. Okay, let's zoom out a little. Are we in radians? Yes, we are. And our other function is 15. Whoops, I do need to say that it is, we'll say f at x equals 15. There it is. Okay, it's just the direct current. Okay. What they want us to do is, I think, they asked us to add the two currents together, so figure out what the combined function is. So if we were to combine these functions, we'll call it h at x, okay? And h at x is going to be the alternating current plus the direct current, okay? And this ends up being 10 sine, we'll still use t because they're using t for time, but for graphics sake, we'll use x there, plus 15. So that's our new h at x. Luckily, there's nothing to simplify here. Okay, like we talked about before, this 10 value is kind of our amplitude for our function. We're used to a sine x. There's really nothing horizontal going on. The only other thing they have, did you guys call this c or d? I can't remember. C, yeah. So this is a vertical shift of 15 units upwards. So if we were to combine the two, we have 10 sine x plus 15. And lo and behold, the new function is centered around the value of 15, which means with our new function, the equation of the axis, okay, you're used to that term, is our c value. Whatever our c value is the equation of the axis, so that's at 15, okay? And using that information, since we know that the amplitude is a value of 10, if this is the equation of the axis at our new number 15, so again, we'll do another rough sketch here on the side, and then we'll sketch it on our lovely graphing calculator. If we're now at, we'll do the new one, actually we'll do it in blue. Our new equation of the axis is here at 15, and we have an amplitude of 10, so this is 15. We know it goes up 10, and then comes back down 10, up 10. It's not a great wave, but what would be our new max and min to this? If our equation of the axis is at 15, we go up 10 units, so what's our peak for this value here? This will be our max. Take a second to think about it. This would be our min. What would the values be if the equation of the axis is 15 and we go up 10 units?
For the max,
yeah,
25.
That's right. So this is at a value of 25. And what would the minimum be? We go down 10 units from 15.
5.
Yeah, it'd be 5. So those are our new maximum values. So in other words, if they were to ask us, and we assume this goes on forever, if they ever to ask us what our domain and range is, depending on how your teacher gets you to write it, do you guys use this concept for domain? X is all real numbers? No? What notation do you use? Is it like just an X such that?
Interval notation.
What does that look like?
The little infinities and the...
Oh, so you go from infinity. Oh, okay. So yours would look like
negative
X.
infinity to positive infinity. if it's just there's no restriction.
Is this it? Less than
No.
x is greater than negative infinity and less than no
You
infinity?
don't use x at all. You just like this.
And I'll write the range while you do that. Range of this function.
Like that.
Oh, just the two endpoints. Oh, okay, so you just do negative and positive. Okay, so that's would be our domain of this function. And for our y value actually has a range. It depends how you guys write it. This is a common style while y such that y is less than and equal to our 25 and greater than and equal to our our value of 5.
So
Okay, so maybe you guys would do
square bracket 5 to square bracket
25.
Yeah.
So do you mean my square bracket like this?
No, like not instead of the curved one.
Oh, geez, yeah.
Instead of the curved bracket, it's this
Just square.
one.
Oh, okay.
Yeah.
Okay, simple. Okay, and it depends what notation your teacher wants there. Okay, but the idea is the idea is the same. So if we were to go look at it, this makes sense. If we put a horizontal line, y at 25, we're hitting the peaks over and over and over again, and those are the times we're hitting it. And if we put another one at y equals 5, and we'll turn the other functions off. Whoops, I turned off there it is, our minimum values, okay? And there we go. And we know we have an equation of the axis at the value 15. This is cutting right through the middle of the function.